All right, let's look at going the other direction. In this case, we're going to be given a graph, and we want to find the sine or cosine function that gives us that graph. Now, because of these things being periodic, there are actually infinitely many ways to come up with the valid equation for any one of these graphs. The reason is, suppose we're given this one, and we're supposed to find a sine or a cosine graph or equation that gives it to us. Well, we could treat it like it's a sine wave that starts here, or we could treat it like a cosine wave that starts here. And so we could get a cosine or a sine equation that'll give it to us. We could also, if we wanted to, treat it like it's a sine wave that starts here but has a negative, it's multiplied by -1. And I guess we could do the same thing down here. We could say it's a cosine wave that starts here and is multiplied by -1. So you can start really anywhere you want to on any peak or valley or any place on the midline and get a valid equation for it. So typically what you want to do is you want to pick something that's nice. On this one, of all the things, I would probably pick this to be my starting point. Reason being, you want to pick something that's close to the origin, and also you want to pick something where it goes through something that you can tell. Like it's obvious there that this hits right at minus pi over 3. Ditto for this. This hits right at 2 pi over 3. This one up here, it looks like it hits at pi over 6, but actually I'm pretty sure it does hit at pi over 6, but it's not one of the things that's given to us on along the axis. So let's start here, and let's treat this as a sine wave that does this. So let's see, first up, recall, you got y equals a sine bx minus c. And there are two equations we need. We need to know that the period is equal to 2 pi over b, and the phase shift, which we mentioned that earlier, but we haven't used it yet. The phase shift is, let's see, the phase shift was c over b. All right, so what is the phase shift? If we pick this to be our starting point, it's shifted over from here backward. So this is a phase shift. In this case, it's minus pi over 3. All right, so we've got the phase shift. The amplitude of this thing is 1, and it's not flipped. So that tells us right there A is equal to 1. So we've got A, we need to find B and C. Well, to find B and C, all we need is the phase shift, this equation, and the period. So let's work out the period of this thing. The period, this thing starts here at negative pi over 3, and if we look at one period, that period ends at 5 pi over 3. So what's the length of this? It's 5 pi over 3 minus negative pi over 3. So that's 6 pi over 3, which of course is 2 pi. All right. So now, let's see. Phase shift, well, let's see. Period is 2 pi, and we know that the period is 2 pi over b. So this right here gives me that b has to be 1. All right, and the phase shift, is minus pi over 3, and the formula for phase shift says phase shift is c over b. All right, so b was 1, so my phase shift is just minus pi over 3 equals c. So it looks like I've got everything I need here. I've got my B, my C, and my A. So let's write this up. That would be y equals sine of 1x minus c. So this is going to be plus pi over 3. Don't mess that up. This is a sine bx minus c. And since my c is negative, I'm adding it. So this should be our answer. Now, of course, we'll check it by graphing it on Desmos. So let's see. Y equals sine x plus pi over 3. All right, let's compare this to the graph we started with and see if they're the same. Well, let's see, do they start in the same place? Yeah, they both, the sine starts at minus pi over 3. Let's see, we get this maximum up here at like pi over 6. It hits down here again at 2 pi over 3. And does it end at 5 pi over 3? Yes, it does. So yeah, this is that's a valid equation for this. We're good. Can we find another one? The answer is yes. We can find more equations for this. Actually, before we do that though, notice something. If you were paying attention and you were thinking about what we did a good while back when we talked about horizontal shifting, you might have looked at this and said, "Oh, this is just a sine wave. It's shifted back pi over 3." So, and it's shifted pi over 3 to the left, so we could just take this and make it sine of x plus pi over 3. And that works, that's fine. The reason we call it a phase shift instead of a horizontal shift is because if you move it over a multiple of the period, then the graph is back to the original. Let's see, how much space do we have here? We got enough space. Let's do this example again. This time, let's say that it's a cosine wave. Or no, let's say it's a sine wave starting here. Okay, if it's a sine starting there, that would be a phase shift of, where is it starting? That's at 2 pi over 3. So a phase shift of positive 2 pi over 3. The difference there also is our amplitude is still 1, but it's flipped. So A is going to be negative 1. B, we don't need to recalculate B. B is still 2 pi because that just comes straight from the period. So all we really need is this equation again. Phase shift equals minus C over B. So 2 pi over 3 equals C over B. I got ahead of myself here. B is not 2 pi, B is 1. 2 pi is the period. 1 is the is B. So this down here is 2 pi over, or it's C over 1. So my C is 2 pi over 3. So you get minus sine of x plus, no, x minus 2 pi over 3. So if I were to graph that on Desmos, it should give me the same graph. Why is it not? Oh, it's because I've got a plus there instead of a minus. Oh, and I left my negative off. So if I finally type it in correctly, it gives us the exact same graph. Sometimes if you want to check and see if it's right, you can like click one on and off and see if they're right on top of each other. All right, Now, in the rest of these notes, I've got several more examples. Let's see, I've got that example, 501, 502, 503, and that's it. So I've got 3 examples left. I'm going to do those in my upcoming videos, but what I would suggest is that you go ahead and maybe try to work those out yourself, and then if you get stuck, then watch the video and see how it goes. Or you might want to watch one more video and then do the last 2. But anyway, I would encourage you to use these as like exercises, because I think they're probably better than some of the problems that are in the book. So anyway, take a look at those, and I will work the rest of the examples for you in the next video.